This is Algebra 1, Semester 1, and it is the, interesting, I'm doing an Algebra 1 lesson, that's okay. I'm going to go ahead and do it for review anyway. This is 0 to Inequalities is the unit. Okay, so Inequalities is a unit. 0, 1 is the lesson, and it's number 1, number lines, and set notation. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we do the actual problem sets, let's show you how to find the notes for your comp book. Let's see here. Let me try to get to the right place, you guys. Here we go. Here, I think I got it. Okay. So go to creatormath.weebly.com, right? Go to that website. You should get to a home page. It looks like this. If you want to know anything about the comp book, please scroll down until you find the words comp book. Read all the directions, follow them, watch all the videos, follow them, follow the due dates, put things where they're supposed to be, and you should have a 90 to 100% on your comp book. You're going to need to know how to find the notes. So the notes for this particular lesson we're filming right now is right here. It's under the tab of the class we're in, and then or of the video I'm making right now. So this is where all of the video lessons, the problem sets, the notes, and the vocabulary algebra practice study PDF for the vocabulary is. If you're not getting 100% on your vocabulary practices, maybe you don't know, but there's an entire PDF right here with every vocabulary word on it we're going to use for the entire school year. Download it to your device, and it is searchable. So Google, how do I search a PDF with whatever kind of device you're using. It is a little bit different for each device. Now we're going to scroll to the semester. Next most important thing is find the semester we're in. And for this particular video, here it is. This is a table of contents. You should have written this a long time ago on pages 2 through 6 of your composition book. If not, stop what you're doing now and do that. There are videos on how to number your pages and videos on great composition books back on the home page where we just were. Otherwise, we're going to scroll down and find this unit. This unit is called Inequalities right here. There are 1, 2, 3, 4, 5, 6, 7 lessons within this. We're on lesson number 1 right here. So this is called Number Lines and Set Notation. It goes on these pages of your comp book. Please don't use this video to determine which pages to put it on, but go to the original table of contents at the time you're viewing this. These page numbers probably will have changed. Here are the notes. We're going to click on this. Fair warning, sometimes I have to open it twice to get it to load. It's a picture of my notes or a picture of the board, depending on what we've got. It's going to talk about greater than, less than, greater than and equal to, and less than and equal to, right? This is called inequalities. So how do we read this? 5 is greater than 2. Negative 1 is less than 4. Negative 2 is greater than negative 6. Negative 8 is less than negative 3. And what teachers have maybe taught you is the smaller side of the arrow points to the smaller number. So negative 8 is smaller than negative 3. 5 is greater than or equal to 5. 4 is less than or equal to 9. That's how you read those. Now we're talking about if we're given a number line, how do we write this two ways? All right, so here's an open circle around the negative 3 and a line to the right. That means it's everything positive above negative 3, but it does not include negative 3 because it's an open dot. So open dot excludes value. Set notation is, here's x is greater than negative 3. That would be a greater than or inequality notation. And then a set notation would be using parentheses. It's got a parentheses negative 3 because parentheses does not include the number. And then it goes up to positive infinity. That's all the way to the right forever. And it's a parentheses because infinity is not a number. All right, one more. Let's do one with a solid dot, and then let's move on and do the actual problems for this lesson. So a solid dot on the negative 3 means that the negative 3 is included. So now we have to say x is greater than or equal to negative 3. Notice the difference. Open dot, just greater than, because it's excluded. Solid dot, greater than or equal to, because it's included. So we need the equals in there, right? So x is greater than or equals to negative 3, solid dot. Now we use a bracket. Bracket shows that the negative 3 is included, as does the solid dot, comma, positive infinity, which means this set notation is that this value goes from negative 3, inclusive because of the bracket, up to positive infinity. Why do we have a parentheses on a positive infinity? Because infinity is not a number, so you cannot include it, you cannot bracket an infinity it must have a parentheses. So with that, let's go look at the vocabulary. They're talking about greater than, less than, greater than or equal to, less than or equal to, open dot, solid dot, parentheses means not included, bracket means included. Negative infinity, positive infinity, and infinity is not a number and therefore cannot be included. Infinity is a concept, you guys, the concept that a number increases forever, either in the positive direction or in the negative direction. Okay, so let's dive into the problems for this lesson, the problem set here. Given this, 5 is greater than 2, how is it read? 5 is greater than 2. I probably should have spelled out 2 right there. All right, given this one, negative 1 is less than 4, negative 1 is less than 4. So there's nothing tricky here. They're just asking us to write in words what the statement says. Given negative 2 is greater than negative 6, how is it read? Negative 2 is greater than negative 6. And you're just, the big thing for students is, if the larger side is, I used to have a teacher say, oh, it's an alligator and they're trying to eat the bigger number, right? So the open mouth of the symbol is toward the larger number. And sure enough, negative 2 is larger than negative 6. All right, and what they mean is the one that's further to the right on the number line, as in larger being more, a larger positive number in that regard. Okay, so given negative 8 is less than negative 3, negative 8 is less than negative 3. 5 is greater than or equal to 5. How is it read? 5 is greater than or equal to 5. All right, just some warm-up practice to give you an idea and to remember what that symbol means. Most students have learned it prior to this class. However, if you hadn't, now's your time. So given 4 is less than or equal to 9, how is it read? 4 is less than or equal to 9. Given this greater than, how is it read? It's greater than. Okay, so this way, greater than. Given this, how is it read? Less than. This way, less than. So we read from left to right. If you're here and it's the larger part, you're reading from left to right, greater than. Now you're reading from left to right. The first thing you hit is the less than because it's the smallest side. So less than. So whatever number here, 4, would have to be less than this one, 8, for this to be a true statement. And just so you know, in geometry they do this for angle. I'm supposed to draw this one like this. This one's supposed to be horizontal. This one's supposed to be at an angle down if I draw it right, which I rarely do. Okay, just to give you that heads up. Given this is greater than or equal to. Given this one, less than or equal to. On a number line, what does an open dot mean? The value is excluded. So if you have an open dot here at negative 3, that was one of our examples already, and it's open, that number's not excluded. Now, we're going to then see, is it go up to the right? If it goes up to the right, it would be everything above negative 3, and above means negative 3 is not included, but negative 2.99999999999, etc., and above is all included in that idea of a set of values. On a number line, what does a solid dot mean? It means the value is included. So again, if you had that 0 and a negative 3, and now you got a solid dot here, it means you've got to have an equals, because it's not only greater than, say it goes off to the right, it's not only greater than negative 3, but it also equals negative 3. So it would be greater than or equal to negative 3. Given a parentheses, how is it read? Well, how is it read may not be what does it mean might be. What does it mean? What does it mean? It means the value is excluded. If we have a bracket, however, then the value is included. Okay, I'll fix those by the time you guys see it. Given this, a plus infinity, how's it read? Positive infinity. And just to be a little bit clear, most textbooks and teachers will not say positive infinity. Most will just say infinity. We drop the positive, but I often like to put a positive infinity in because that gets students ready to understand, hey, if there's a positive infinity, guess what? There's a negative infinity, right? Negative infinity. So here's a number line. Here's 0. Off to the right forever, positive infinity. Off to the left forever, negative infinity, because you're increasingly getting negative as you go to the left. So negative infinity students understand better. If I first introduce a positive infinity, they now know, hey, there's probably an opposite coming, a negative infinity. Fair enough? Okay, is infinity a number? No. Infinity is not a number, you guys. It is a concept that numbers either increase or decrease in the form of negative infinity forever. Right? So if numbers go off to the right in the number line, they're increasing in a positive manner forever. And if numbers go off to the left on the number line, they are increasing in a negative number forever. They're getting bigger as a negative number. All right. Given the following number line, how can we express what is being communicated in equality and set notation? So inequality and set notation. So two things. This is an open dot, so it does not include the -3. And we've gone over this example a few times, so hopefully it looks familiar. Well, what we want to say here is inequality. X is greater than -3. And that's all that says. It goes off to the right forever, but it does not include the -3. So that's this one. Then set notation uses either parentheses or brackets. Because it's not included, we use a parenthesis. Then it goes off to the right forever, which is plus infinity, and we cannot use a bracket, we must use a parenthesis because it's not a number, it's a concept. This would be set notation, okay, and notation. And of course, in math, we try to confuse students as much as possible, and that's sarcasm, okay, I'm sorry about that, apologize for that. But you know, what students are used to is a coordinate location. They're used to something like, oh, if I have an x and y axis, this is 1 and this is up 2, so this would be 1, 2. So they're used to seeing a coordinate location. Now all of a sudden they see this. You have to separate these in your mind. They're completely different topics, right? This is a coordinate location. This is a set notation, which describes a set of numbers from -3, not included, all the way up to infinity. That's a lot of numbers, right? An infinite number of numbers. So set notation is completely different from coordinate notation. Don't mix them up and don't fret about it. Given the following number line, how can we express what is being communicated in an inequality and set notation? So now we have a solid dot, same thing, so we have an x is greater than or equal to -3. We must now have an equals because the solid dot includes the -3 value. In terms now, I must use a bracket because the -3 is included, comma, all the way up to the positive infinity forever. And you can't use a bracket, you must use a parentheses because infinity is not a number, it's a concept. So it can never be included. You can only include an actual number. Given the following number line, how can we express what is being communicated in inequality? So this one's open dot. It looks like 1, 2 maybe. That looks like a 2, 3, 4, 5. Okay, so that's 2. So x in this case is everything less than 2. All right, x is less than 2. Oh, I didn't mark these up here. This one and this one. All right, x is less than 2. Now let's use set notation. So is the 2 included? No. So parentheses, and it's larger, and everything's going back this way. So I'm going to write the right side first because it's here. Where does it come from or where does it go? It goes to or comes from negative infinity. So it starts way back at the left forever to the left and comes up and stops right here, not including the 2. So there's no equals involved. But now they're going to test us by making it a solid dot. So because it's a solid dot, now x is, and I might keep this one in the view just so you can see both. So this was open, so x was less than 2. This is closed, so x is less than or equal to 2 because now it's equals. It includes that value because of the solid dot. Therefore, we need an equals. Therefore, we need a bracket. Right? And I'm writing it kind of in reverse because my brain is thinking starting here and going in reverse. So I started at the right and wrote it going to the left. So I have an x is less than or equal to 2, true, and I have this set notation, parentheses, negative infinity, comma 2, bracket. All right, look at the notes, write them in your book. It's unusual, but it's not that crazy, okay? You can do it. You can get this. Just pay attention and separate in your brain coordinate locations from set notation. This is Algebra Semester 1, and this is the unit called Inequalities, and this is the first lesson called Number Lines and Set Notation on CreatorMath.com under the Algebra 1 tab. Hope this helps.